Okay, in this video I'm going to continue the discussions of the Cisco ONS 15454 system. Here's the multi-service provisioning platform. Here's the multi-service transport platform. This is the main unit of the multi-service transport platform, and we also have the M6 unit of the multi-service transport platform and the M2 unit of the multi-service transport platform. So we're really focusing on multi-service transport platform components here, and we're going chapter by chapter through the gigantic provisioning manual that comes online with this ONS 454 system. And so here we're talking about Chapter 7. Chapter 7 is about dispersion compensation modules. There are two types of cards here, the TDC-CC and the TDC-FC. Okay, and I'll show you these two cards here. These two cards, as you may recall, when we were talking in Chapter 5 about optical amplifiers, a lot of the optical amplifiers had what was called a mid-stage access, and basically here's the figure from page 5-33 of this manual, figure 518, showing that in the EDFA card we had a pre-stage and a post-stage, and in between we had connectors that allowed us to set up external mid-stage loss, which is typically dispersion compensation. And that's why this is called DC transmit and DC received. DC for dispersion compensation. So there's where these cards fit in. And there are two cards available. See if I can get this here. And these are tunable dispersion compensators. So it's the TDC. And each one of the cards can give 16 different values of chromatic dispersion, ranging from 0 to negative 1650 picoseconds per nanometer on the TDCC, and ranging from 0 to negative 675 on the TDC-FC. CC stands for coarse chromatic, or coarse C-band. FC, I guess, stands for fine C-band. And basically, on the CC version, the chromatic dispersion value is in increments of 110. So you see 0, minus 110, minus 220, minus 330, all the way up to minus 1650. On the FC version, they're in increments of 45, 0, minus 45, minus 90, etc. Okay? How do they do this? How do they get 16 different values? Well, they have, here's the block diagram showing how this is laid out. There are 4 dispersion compensation coils here. These are coils of DC fiber that I talked about in a previous video. And each of the coils is switched in or out with a 2x2 switch. The 2x2 switch works to either send the signal through the coil or not. So if we have a 2x2 switch, it can be in either the bar or the cross state. And if this switch is in the bar state, then the input is mapped directly to the output without going through the coil, which I'll draw like this. And if it's in the cross state, the input is mapped across into the coil and then back in through the cross state and back out. So this is how a 2x2 switch either bypasses the coil or sends it through the coil. And we get 16 different values of chromatic dispersion through a 4-coil sequence. In other words, on the 110, on the coarse one where we have increments of 110, apparently the coil values are 110, 220, 440, and 880. And so they add up like a binary number. Okay, so you can make any combination of the chromatic dispersion there. I guess I'll show you a quick page where we have the 110, the 220, 330, and the 440. What am I doing? The 110, the 220, the 440, and the 880. If we want to get a 110, we just use coil number 1. If we want a 220, we use just coil 2. If we use coils 1 and 2, we get the 330. Coil 4 by itself gives us 440. Coils 1 and 3 gives us 550. Coils 2 and 3 gives us 660, etc. Building up in a binary fashion. Okay, so that's how these things work. There's a fair amount of loss associated with these 2x2 switches, and there's a lot of loss associated with the dispersion compensating fiber. Here's a separate document which you could Google, Cisco ONS 15454 Tunable Dispersion Compensation Unit, and find. This was published in 2010. This shows a picture of one of the DCM modules. It's a single width card for the ONS 15454 chassis. Okay, and this card shows the same basic diagram, but also gives you some specs here, and I hope you can read them. They're smaller than normal type. The wavelength range is the C-band on both of them. Maximum insertion loss is 12.5 dB for the coarse unit and 9.5 dB for the fine unit. And they don't give any spec at all on dispersion slope over the wavelength range. And so I mentioned in a previous video that you do have to worry about that. And these units are intended to operate on the muxed signal, that is up to 40 wavelengths coming through at once, and apparently they're not speccing out the wavelength dependence of the dispersion here. These two tables give us the maximum insertion loss for various values of the chromatic dispersion. Okay, and this is the block diagram that shows the block diagram. No, this is a different document, sorry. Okay, so there's your dispersion compensating unit, and I guess that's all I'm going to say about those units. Those units are used with the EDFAs for mid-stage amplification in the EDFAs. Okay, thanks.